we are UdeGSpace and this is our mass rover prototype UT1. In the current edition, we will be using a centrifuge as the main instrument to mix the samples and the reactants. We will be using colorimetric analysis to determine the concentration of different analytes: nitrate, nitrites, phosphate, hydrogen amino acids, proteins, carbohydrates, etc. The rover will be equipped with gas detecting sensors as well, including methane, carbon dioxide, and benzene.
The laboratory is designed to have an almost hermetic closure, so the sample contamination will not be a problem. The practicality of the test system base stations and control points allow the pre-programmed sequences to have greater precision at the time of execution. This makes it much faster and the error is lower. The laboratory is designed by stations, in a way that are distributed in the independent slots.
The suspension system features independent support for each wheel. It's mainly made up of upper and lower different length control arms, which are strategically attached to the chassis at the bottom and sides due to the motion ratio.
The rover rides on 4 10 inches inflated rubber wheels. This type of wheel is lame and had quite good traction on rocks.
It's slow and rough soil, since it's of rough wheels.
The gear and motor for each wheel is mounted directly to the shaft bearing and is protected by the lower arms.
The robotic arm is made up of a jointed 5 degrees of freedom design. The arm is designed for use in 2 competition tasks. These include equipment servicing and astronaut assistance. The design includes a 3 degrees of freedom grist, pitch and roll, and a gripper at the end. An adhesive rubber was added to optimize grip when adapting to objects to be picked up and moved. The arm is able to perform the required operations such as typing on a keyboard, as well as tightening a screw, pushing buttons, flipping switches, and inserting a memory USB stick.
In the autonomy team, the rover geolocation is performed with a GPS and a set camera. This will help us to map the environment, which is described using the method of occupancy cells and graph traversal algorithms work. We test the routing algorithms and analyze the behavior of a rover when given a point B to reach from a point A. We develop a simulation in Gazebo modeling the rover, and with the help of ROS, we perform the communication of the subsystems.
The rectangular frame shape serves as a balance mounting point for the suspension system, electrical box, and other devices such as the antenna. Acrylic porous sheet covers all the sides of the frame as a protective shield from dust while still allowing airflow. The assembly of the suspension system is now optimal with this new design, which includes modularity in the frame. It now uses a jig assemble system. The last improvement was to regulate the center of gravity to its dead center.
For the communication and power, we ensure the wireless connection between the base station and the rover by using a high-power radio for a 2.4 GHz connection. With sector and omnidirectional antennas for line-of-sight communication using the TCP/IP protocol through ROS-Mera operating system that allow all the boards on the QD1 to be remotely controlled, enabled of completing each of the tasks of the competition. For the power subdivision, we implement a 12-volt 35 amps lead battery and a step-up and step-down converters so that we can power the different devices on the vehicle.